Today I am giving the 8th video on topology. Okay, we will start with the definition, that is path product. What do you mean by path product? Let f1 and f2 be paths in a topological space x2 such that f1 of 1 equal to f2 of 0. Then the path product f1 star f2, that is from I to x, where I is 0, 1, close into 0, 1, is defined by f1 star f2 of x equal to f1 of 2x. When 0 less than or equal to x, less than or equal to half. And f2 of 2x minus 1 when half less than or equal to x, less than or equal to 1. This is the way f1 star f2 is defined. f1 star f2 of x equal to, that is expressed in two ways, that is f1 of 2x for x varies in the closed interval 0 half, and f2 of 2x minus 1 for x in the closed interval half 1. Note that f1 star f2 is continuous. That is actually follows from the pasting lemma. Next definition, a topological space x2 is locally pathways connected. Locally pathways connected at a point P if for each neighborhood, capital U of P, there is a pathways connected neighborhood capital V of P such that V subset are equal to U. A topological space x2 is locally pathways connected. Local in the sense we are taking about a point. When it is true, if for each neighborhood U of P there is a pathways connected neighborhood V of P such that V subset are equal to U. That is the definition. x2 is called locally pathways connected if it is locally pathways connected at each of its points in x. If it is true for every point in x, then we say capital X is locally pathways connected. Next theorem, at x2 be a connected locally pathways connected space, then x2 is pathways connected. That is, if it is locally pathways connected, x2 be a connected locally pathways connected space, then x2 is pathways connected. x2 be a connected locally pathways connected space. Connected ആണ്, locally pathways connected ആണ്. Then x2 is pathways connected. That's what we have to prove. Proof. Taking a point, let A in x, take capital A equal to set of x in x such that there is a path joining A and x. A to x there is a path. And such x, the collection of such points x, so what capital A. If f from I to x is given by f of x equal to a for all x in I, f0 equal to a, f of 1 equal to a, then f is a path from a to a. Trivial at every point. This implies a is in a, small a is in a, that is a is non-empty. First claim is a is open. You are taking a point x in a, and there is a path f1 from I to x such that f1 of 0 equal to a and f1 of 1 equal to small x. But capital X is locally pathways connected at x. Therefore, corresponding to each neighborhood, capital X of small x, there x is a pathways connected neighborhood, capital V of x, such that x in V subset are equal to x. We show that capital V subset are equal to A. Taking let y in V, point y in V, then x and y are in V, and V is pathways connected. Therefore, there is a path f2 from I to x such that f2 of 0 equal to small x and f2 of 1 equal to y. Then the product path f1 star f2 is a path from a to y. That is x in V subset are equal to a. Hence the claim. That is A is open. Claim 2 is A is closed. That is, we are going to show that A is both closed as well as open. A is closed. Let B neighbor, that is closed trophy, This implies B in X, since X is locally pathways connected at B, corresponding to the neighborhood capital X of B, there exists a pathways connected neighborhood capital V of B, such that B in V is subset or equal to X. This implies V intersection A is non-empty. We are taking an element C in V intersection A, that is C in V and C in A. Take first case, C in A implies there is a path F1 from I to X such that F1 of 0 equal to A and F1 of 1 equal to C. Now C in V, second case, C in V implies B and C in V. As V is pathways connected, there exists a path F2 from I to X such that F2 of 0 equal to C and F2 of 1 equal to B. So F1 from A to C, F2 from C to B, so that the path product F1 star F2 is a path from A to B. This implies B is in A, or A closure is subset or equal to A. But actually we know A is always subset or equal to A closure. So from these two we can write A equal to A closure, or A is closed. So we have proved A is open as well as A is closed. Since X2 is connected, there cannot be a non-empty proper subset of X which is both open and closed. So we must have A equal to capital X. Taking alpha and beta in capital X. What is capital X? That is A itself. X equal to A. Then there are paths F1 and F2 in X joining small a to alpha and small a to beta respectively. And the reverse path F1 bar of F1 given by F1 bar of X equal to F1 of 1 minus X is a path from alpha to A. Actually F1 bar is from alpha to A. F2 is from A to beta. So F1 bar star F2 is from alpha to beta. Therefore the path product F1 bar star F2 is a path from alpha to beta. That shows that X is pathways connected.